Beneath the stone floors of the world's most sacred temples lies a forgotten power grid. We are uncovering the buried infrastructure beneath ancient sacred sites, the hidden engineering that powered entire metropolises. By the end of this journey, you will see ancient history not as a collection of ruins, but as a blueprint for how to build sustainable cities of the future. What if the key to a city's survival was not its grand monuments, but the secret channels running underneath them? And why would ancient engineers hide their greatest work below holy ground? What does it truly mean for a civilization to be advanced? These hydraulic arteries beneath Teotihuacan were a masterpiece of foresight. The city's engineers did not just build canals, they built a dynamic, living system. They carved maintenance tunnels alongside the water channels, narrow passages that allowed workers to walk deep underground, inspecting the flow and clearing any blockages. This reveals a profound understanding of long-term urban survival. The system was not a static monument. It was designed to be cared for, adapted, and sustained over centuries. It functioned like the circulatory system of a living body, with a sacred spring at the pyramid of the sun as its beating heart. This was not merely plumbing. It was a form of geoengineering that turned a challenging environment into a place of abundance. The entire city, from its grand temples to its humblest homes, was elevated by this hidden network. How did such comprehensive knowledge develop, and why was it so deeply intertwined with the sacred? The answer may lie far from Mexico, in the capital of another empire that mastered the art of hiding its power in plain sight. While the engineers of Teotihuacan carved maintenance tunnels for their water, the Romans perfected a different kind of subterranean art, one of pure integration. Beneath the circular temple of Vesta in the Roman Forum, where the sacred flame representing the city's life was kept eternally burning, archaeologists have uncovered a secret. This was no isolated shrine. Its foundations were laced with channels connecting directly to the city's vast aqueduct network. The pure water flowing beneath the temple served a dual purpose, supplying the city and performing the essential ritual purifications for the Vestal virgins. The spiritual and the practical were one and the same. Recent surveys using ground-penetrating radar have mapped chambers under other major temples, revealing them to be hidden distribution hubs. Water was channeled from these sacred points to public baths, fountains, and even private homes. There is even a compelling theory that the sacred fire itself was not just fed by wood, but may have been sustained by geothermal heat channeled from below, turning the temple into a natural power plant. This integration went even deeper. The Cloaca Maxima, the great sewer we remember for its waste, began its life as a sacred civic project, a monumental drainage channel that transformed the marshy land between Rome's hills into stable, holy ground for its most important temples and forums. As engineering professor Dr. Alessandro Lonaro explains, the foundations of these sacred structures were not just stone. They were sophisticated water management systems designed to prevent flooding and structural damage while quietly directing the city's flow. The Roman genius lay in this seamless blending, where every temple was a functioning node in an urban utility network, its spiritual significance masking its immense practical power. They solved multiple problems with single, elegant solutions, understanding that a metropolis could not survive on visible grandeur alone. It required an invisible, functional backbone woven directly into its most sacred spaces. This same principle of hidden mastery emerges thousands of miles away in the dense jungles of Cambodia. Deep within the Cambodian jungle, the stone towers of Angkor Wat rise as a testament to spiritual ambition. Yet for centuries, the true scale of the city surrounding this temple remained a complete mystery, hidden beneath a dense canopy. The breakthrough came with lidar, a laser technology that digitally strips away the forest, revealing the ghost of a metropolis below. This was not just a temple complex, it was the largest pre-industrial city on Earth, a hydraulic empire powered by water. Its magnificent moats were far more than symbolic boundaries. They were massive storage reservoirs, holding billions of liters of water to sustain nearly 1 million people. A vast, gridded network of canals and underground channels acted like arteries, distributing this lifeblood to immense rice paddies, transforming seasonal monsoons into year-round agricultural abundance. Researcher Dr. Damian Evans from the University of Sydney has mapped a system of astonishing sophistication. It included overflow mechanisms to prevent catastrophic flooding during heavy rains, and sedimentation tanks that allowed silt to settle out, providing a form of early water purification before it entered the main reservoirs. The scale is almost incomprehensible. The West Barre Reservoir is an artificial lake measuring 8 kilometers long and 2 kilometers wide, a monumental feat of engineering that would be ambitious even today. This entire hydraulic landscape was orchestrated with sacred precision. The temples were not passive monuments, they were active control nodes, strategically positioned to manage the flow of water across the urban landscape. The perfect sacred geometry of Angkor Wat's design was in lockstep with the practical needs of water distribution, creating a seamless bond between spiritual belief and physical survival. This challenges everything we thought we knew about ancient technological capabilities, revealing a civilization that mastered its environment by weaving its infrastructure into the fabric of the divine. And as we will see, this pattern of sacred engineering was not unique to the Eastern Hemisphere, but blossomed independently with breathtaking ingenuity in the ancient Americas. High in the Peruvian Andes, the stones of Chavin to Huantar tell a story of two rivers merging, but the true convergence was happening far below the surface. This temple complex is a labyrinth, not just of ceremonial spaces, but of meticulously engineered underground channels. Archaeologist Dr. John Rick from Stanford University has spent decades mapping this subterranean world, revealing a system where the line between spiritual ceremony and practical engineering completely vanishes. The Chavin engineers carved stone-lined tunnels to capture the relentless flow of mountain streams, but they did so with a dual purpose. These channels were not silent. They were designed to create a roaring, percussive sound as water rushed through them, a sound that would have filled the ceremonial galleries during rituals, transforming the temple into a living, breathing entity. This was architecture you could hear, a spiritual experience powered by hydraulics. The system's genius extended to pure survival. The Andes are subject to torrential rains, and the temple's precise network of drains and overflow channels was a masterclass in flood prevention, protecting the sacred heart of the complex from being washed away. The strategic choice to build at the confluence of two rivers was no accident. It was a deliberate move to harness immense hydraulic power, controlling the water's force to serve the settlement. Recent excavations show these underground arteries did not end at the temple walls. They stretched outward, connecting to residential districts and feeding vast agricultural terraces, proving the entire community was sustained by this hidden grid. The Chavin culture possessed a profound, intuitive understanding of hydrodynamics. They manipulated water pressure, directed flow, and even incorporated basic filtration, all without any modern tools, achieving a seamless integration of the sacred and the municipal. This raises a profound question: how did these cultures, separated by oceans, arrive at such a similar and brilliant solution? The pattern is undeniable: and it leads us to another American marvel, a city built in one of the most arid landscapes on the continent. Across the American continent, another city rose to staggering heights, not in the mountains or jungle, but on the fertile floodplains of the Mississippi River. Cahokia was a powerhouse of the ancient world, and its secrets were buried not in stone but in earth. Beneath its great earthen mounds, archaeologists have uncovered a complex that functioned as both a celestial clock and a climate control network for the entire metropolis. The most famous of these structures is Woodhenge, a vast circle of towering wooden posts, but the true genius of this design lay beneath the surface. The posts were not simply planted in the ground, they were the visible markers of a deeper system, anchoring root cellars and food storage chambers that delved into the cool, stable earth. These subterranean rooms maintained a consistent temperature year-round, acting as a natural refrigerator during the sweltering summers and a frost-free pantry through the bitter winters. This was not just a place to store food, it was a sophisticated method of managing the city's most vital resource, its food supply across all seasons. Researchers from the University of Illinois have found evidence that takes this even further. They uncovered traces of underground clay pipes, carefully laid channels that may have distributed heat from central, ceremonial fire pits to various structures throughout the city. Imagine a form of early central heating where warmth generated in a sacred space was piped to warm homes or public buildings, turning spiritual ceremony into a source of communal comfort. The entire city was laid out with this profound integration in mind. The precise positioning of the mounds and their underground features aligned perfectly with the solar and lunar cycles. A priest standing at the summit of Monk's Mound would not only be at the spiritual apex of the city, but also at the perfect vantage point to observe the sunrise over Woodhenge, marking the solstices and equinoxes with pinpoint accuracy. This celestial knowledge was not abstract, it was the very engine of their agricultural planning, dictating when to plant and when to harvest for a population that may have reached tens of thousands. Cahokia's buried infrastructure reveals a society that saw no separation between the heavens and the earth. Their sustainable city was built on an integrated design that connected cosmic cycles with practical needs, from food storage to community warmth. This holistic approach represents a lost paradigm of city building, one where every element from a wooden post to an underground chamber served multiple interconnected purposes. And as we will see, this same principle of sacred integration was being engineered on an equally grand scale in the ancient cities of the Middle East. The desert city of Petra reveals a paradox of survival. In a landscape of rock and sand, the Nabateans did not just build a city, they built a hidden water grid that turned scarcity into abundance. Beneath the famous rose-red facade of the treasury and the other monumental tombs lies a forgotten world of channels, cisterns, and dams. This system was designed with a brilliant understanding of the desert environment. It captured the violent, seasonal floodwaters that rushed down from the surrounding mountains, water that would otherwise be lost in minutes. The Nabateans did not merely collect this water, they perfected it. Their engineers built sophisticated filtration tanks, using layered basins of sand and gravel to purify the silt-laden torrents before the water ever reached a home or a public fountain. This was a form of ancient water treatment, ensuring a clean supply for a population that may have reached 30,000 people, German archaeologist Dr. Robert Wenning has studied the precision of this network, noting how it included clever pressure regulation mechanisms and overflow channels. These features acted as a release valve for the system, preventing pipes from bursting during the rare but devastating cloudbursts. The true masterpiece, however, was the narrow, winding canyon that serves as the city's main entrance. Carved into the towering walls of this gorge were hidden water channels. These conduits were protected from the blistering sun, which minimized evaporation, and from contaminants, creating a shielded aqueduct that delivered a continuous flow directly into the heart of the urban center. The Nabateans transformed a seemingly inhospitable landscape into a thriving oasis through engineering that was meant to be unseen. Their spectacular architecture was merely the surface expression of a far greater subterranean genius. This approach to managing a precious resource offers a powerful lesson for our own modern cities grappling with drought and water security. It proves that a civilization's true strength often lies not in what it displays to the world, but in what it conceals for its survival. This principle of underground mastery was taken to its absolute extreme by another culture, one that carved not just channels, but entire cities deep beneath the earth. The silence of Malta's underground holds a strange and persistent hum. Deep beneath the island's sun-baked surface, the Hal Saflieni hypogeum is not merely a series of burial chambers, but a labyrinthine structure carved with an almost supernatural understanding of energy. This three-level complex descends into the limestone, a subterranean temple where the very walls seem to listen and respond. Within the so-called oracle room, a deep voice spoken into a specific niche does not just echo, it resonates, vibrating through the stone floor and up into the body of the speaker. The sound amplifies, traveling through interconnected chambers in a way that feels less like an accident and more like a designed feature. Archaeoacoustics researcher Dr. Fernando Coimbra has mapped these sonic pathways, revealing how the hypogeum's builders sculpted the rock to trap and channel specific frequencies. A single chant or drumbeat could be transformed into an overwhelming sensory experience, reverberating through the darkness to reach every person in the complex simultaneously. This was not just architecture for the dead, but for the living, a technology of sound that could induce altered states of consciousness or transmit messages across vast underground distances without a single wire. The engineering genius extends beyond acoustics. The hypogeum is intricately linked to the island's natural aquifers, with carved channels that may have directed the flow of water and air. These passages would have provided essential ventilation for large gatherings held deep underground, but they might have served a more subtle purpose. The movement of air and water through these precise conduits could have created shifts in air pressure, potentially generating subtle electrical charges in the surrounding rock, a form of natural piezoelectric effect. The builders appear to have positioned their most important chambers at geological junctures where these energy properties were naturally amplified. They were not just using the earth, they were collaborating with it, harnessing its inherent physical forces to power their rituals. What we are uncovering is a prehistoric paradigm where spiritual practice and hard physics were one and the same discipline. The sophistication of this understanding, dating back over 5,000 years, forces us to ask a difficult question. Why does our timeline of technological progress so often ignore these profound examples of integrated design? The hypogeum stands as a silent challenge to our assumptions, a masterpiece of environmental engineering hidden in plain sight. This same drive to harmonize with the Earth's energy is echoed thousands of miles away in the volcanic highlands of Mesoamerica. Beneath the towering pyramids of Chichen Itza, the true lifeline of the city snakes through absolute darkness. Throughout the Mayan world, these natural sinkholes, known as cenotes, were far more than sources of water. They were sacred portals to the underworld, revered as the home of the gods. Yet this spiritual significance masked a brilliant feat of engineering. Recent explorations using laser scanning have mapped vast cave systems beneath the city, revealing that the Maya did not simply use these caves, they actively engineered them. Deep underground, they constructed stone walls to direct the flow of water, carved channels to guide seasonal rainwater, and built large plaster-lined chambers to act as subterranean reservoirs. These were not random modifications, they were a deliberate transformation of natural geology into a managed public utility. Dr. James Brady from the University of California has documented systems that stretch for kilometers, a hidden grid designed to capture and filter rainwater through the limestone, providing a clean, reliable supply during the long, punishing dry seasons. The Maya possessed a deep understanding of hydrogeology, knowing exactly where to tap into underground rivers and how to manipulate the cave structure to create a stable water table. Their spiritual belief that these were holy spaces ensured their protection from pollution and neglect, weaving practical necessity directly into the fabric of their cosmology. This was a unique form of sustainable design, one that worked with the land rather than against it. The entire urban landscape was supported by this invisible, sacred infrastructure, allowing metropolises to flourish in an environment where surface water was scarce. This holistic worldview, where every physical need was tied to a spiritual duty, created a resilience that lasted for centuries. It is a pattern of sacred engineering that resonates across the globe, emerging with equal ingenuity in the ancient river valleys of South Asia. While the Maya were mastering their sacred cenotes, another civilization was perfecting the art of urban living on an industrial scale. The streets of Mohenjo-Daro were not paved with gold, but with something far more valuable, a hidden grid of brick-lined drains running beneath every major avenue. This was not a partial system for the elite. It was a comprehensive, city-wide network that connected to nearly every home, a feat of municipal planning unmatched for thousands of years. Each house had its own bathing area with a sloped floor, and wastewater was channeled through terracotta pipes set into the walls, feeding directly into the covered drains under the streets. The genius, however, lay in the details. The system was not just a series of ditches, it featured carefully designed sedimentation tanks. These were sunken chambers where water would slow down, allowing solid waste and valuable minerals to settle to the bottom before the cleaner water flowed onward. This was not merely about disposal, it was a form of early resource recovery, where materials like sand or even bits of metal could be collected for reuse. Archaeologist Dr. Jonathan Mark Kenoyer points to the presence of uniform, brick-lined manholes as the system's most telling feature. These were not accidental gaps, they were deliberate access points, allowing city workers to descend underground and clear any blockages, ensuring the entire network remained functional for generations. The entire system was built with a precise gradient, a subtle slope calculated so that waste and water would flow steadily away from residential areas without any need for mechanical pumps, relying entirely on gravity. This invisible, self-cleaning infrastructure was the bedrock of public health for a city that may have housed 40,000 people. At the city's spiritual heart stood the Great Bath, a watertight pool sealed with finely fitted bricks and a layer of natural tar. This was no stagnant pond. It was fed by a dedicated well and had a large, corbelled drain to efficiently manage overflow, a masterpiece of hydraulic engineering designed to maintain ritual purity through physical cleanliness. The same principles that kept the city healthy were embodied in its most sacred space. The scale of this knowledge is what is truly staggering. The same standardized brick sizes, the same drainage designs, and the same urban layout have been found in other Indus Valley cities like Harappa, spread across a vast territory. This suggests a shared, codified knowledge of city building, a unified vision for urban life that prioritized collective well-being through invisible systems. Mohenjo-Daro's buried infrastructure represents a pinnacle of ancient civic engineering, a silent partner in the city's daily life that rivals the sophistication of many modern systems. This drive to build sustainable, healthy cities was a global phenomenon, and our journey now takes us to the Mediterranean, where another island culture developed its own unique and breathtaking underground solutions. The Minoan Palace of Knossos was a city built above a hidden circulatory system. Beneath its vibrant frescoes and grand courtyards, a network of terracotta pipes channeled fresh water from mountain springs directly into the heart of the complex. This was not a simple ditch, it was a masterpiece of hydraulic engineering, laid with a precise gradient so that gravity alone would ensure a constant, reliable flow to palaces, towns, and farmlands. The Minoans understood their environment intimately, designing advanced drainage systems that did more than just prevent flooding during Crete's heavy rains. They captured the deluge, channeling stormwater into deep, plaster-lined cisterns for storage, turning a seasonal threat into a resource for the dry months. British archaeologist Sir Arthur Evans, who first uncovered the palace, marveled at the sophistication of this setup, noting how it included settling tanks and early filtration methods. These features ensured water quality was maintained, with cleaner water reserved for drinking and other supplies used for agriculture and sanitation. The very location of the palaces was a calculated decision, positioned where underground water sources and specific geological features could work in their favor. These natural formations enhanced ventilation, pulling cool air through the lower levels and providing a form of passive climate control that kept the stone structures livable under the Mediterranean sun. Recent work by researchers like Dr. Sandy McGillivray points to an even deeper layer of complexity. Some of these subterranean channels appear to align with areas used for ritual, suggesting the sound of flowing water or the act of accessing a hidden spring was part of Minoan religious practice. The gurgle of water in a dark conduit beneath the temple may have been the voice of a goddess. This seamless fusion of practical need and spiritual belief created a profoundly resilient urban environment, a civilization that thrived for centuries because its infrastructure was woven into both the land and its cosmology. This pattern of integrated design, where the earth itself is a partner in building, echoes far beyond the Mediterranean, reaching all the way to the misty landscapes of ancient Britain. The great stones of Stonehenge stand as a monument to what we can see, but their true power may have come from what we cannot. For centuries, we believed this was a solitary temple to the sky, an astronomical computer built to track the sun and stars. Yet the ground beneath the stones holds a different story, one of hidden networks and integrated systems. Recent geophysical surveys have peeled back the turf to reveal a startling subterranean landscape. This is not an empty plain. It is a complex grid of deep pits, artificial channels, and what appear to be sealed chambers, all arranged in deliberate patterns that mirror the celestial alignments of the stones above. Archaeologist Dr. Mike Parker Pearson has traced a crucial part of this system, a connection between the monument and the nearby river Avon. His work suggests that underground water channels link the two, creating a ceremonial pathway for processions, but also serving a practical role in managing the water table and directing seasonal runoff away from the sacred site. The stones themselves were not placed at random. Their locations correlate precisely with underground geological faults and concentrations of quartz-rich rock. When struck or subjected to pressure, quartz can generate small electrical charges, a phenomenon known as the piezoelectric effect. This creates a space where energy and sound behave in unusual ways. Within the circle, sound echoes and amplifies in specific spots, while magnetic readings can show subtle anomalies. The builders may have intentionally harnessed these properties, using the Earth's own energy to power ceremonies or create sensory experiences that felt truly otherworldly. Even the massive earthworks surrounding the henge, the ditches and banks we once saw as simple boundaries, were part of this integrated design. They functioned as a sophisticated water management system, collecting rainwater and controlling drainage, all while defining a sacred space charged with meaning. This was not merely an observatory. It was a powerhouse, a carefully engineered environment where the heavens, the earth, and the unseen forces below were woven into a single, functioning whole. This sophisticated understanding of landscape engineering did not exist in isolation, but found a powerful parallel in the highlands of ancient Anatolia. The stone circles of Göbekli Tepe are humanity's oldest known temple, but their true secret lies in what they channeled from the sky. Carved over 11,000 years ago, long before the invention of writing or the wheel, this site reveals a stunningly advanced understanding of engineering. Beneath its massive, enigmatic T-shaped pillars, archaeologists have uncovered a labyrinth of subterranean channels. These were not random gullies. They were a sophisticated network of drains, meticulously carved into the bedrock to capture and direct every drop of precious rainwater. The German archaeologist Dr. Klaus Schmidt, who first brought the site to world attention, documented how this system served a dual purpose. It protected the soft limestone temple foundations from being washed away by sudden downpours, while simultaneously funneling water to hidden storage areas. The strategic placement of the great pillars and circular enclosures was no accident. It directly correlates with natural underground water sources and the flow of rainfall across the hilltop. This suggests the site was chosen not just for its spiritual resonance, but for its practical potential as a water harvesting hub. Recent research posits that Göbekli Tepe may have functioned as a regional center, a place where early Neolithic communities gathered not only to worship but to share and develop vital knowledge of water management. The sophistication of these systems, built by hunter-gatherers, completely upends the traditional narrative that agriculture and settled life had to come before monumental architecture and complex engineering. Here, spiritual practice and practical ingenuity appear to have emerged together, hand in hand, as two sides of the same revolutionary impulse. Understanding Göbekli Tepe forces us to abandon outdated assumptions about prehistoric capabilities and recognize a lost chapter in human history where survival and the sacred were one. Our journey into these hidden networks now takes us to ancient China, where another civilization developed its own breathtaking underground solutions. The silent guardians of Xi'an's terracotta army were protected by a hidden engineering marvel. While the world marvels at the thousands of clay soldiers, the true genius lies beneath their feet in a drainage system of astonishing complexity. This was no simple network of ditches. Archaeologists have uncovered meticulously laid channels of terracotta pipes and brick-lined tunnels that did more than just divert rainwater. They were designed to actively manage the groundwater table, creating a stable, dry environment that has preserved these fragile artifacts for over 2,000 years. This same principle of subterranean control was applied to the entire ancient capital. Professor Zhang Zhongpei's research reveals a city underpinned by a grid of wells, storage chambers, and connecting tunnels that formed a resilient public utility. These underground spaces were not dark and stagnant. Strategically placed ventilation shafts, engineered to capture prevailing winds, maintained fresh air in deep storage areas and even in the living quarters above, ensuring both the preservation of goods and the health of the populace. The integration went even further. Some of the longest tunnels have been found to connect to natural geothermal vents, a clever form of ancient central heating. During the bitter northern winters, this captured earth warmth could be channeled through the subterranean network, taking the edge off the cold in palaces and administrative buildings. The very locations of these important structures were chosen with this hidden infrastructure in mind, creating urban environments where practical needs for water, air, and warmth were seamlessly met by an invisible, silent partner. This holistic approach to city planning, which balanced massive populations with their environmental footprint, allowed Chinese dynasties to thrive for centuries. It was a philosophy of buried power that found a stunning parallel in the desert empires of ancient Persia. The deserts of ancient Persia conceal a hidden river, a ribbon of fresh water flowing silently for dozens of kilometers under the burning sands. This was the qanat, a masterpiece of engineering that turned barren landscapes into flourishing gardens. These were not mere tunnels, but carefully calculated subterranean aqueducts, tapping into mountain aquifers and guiding the water down a gentle, relentless slope to the city gates. The entire system was a triumph of gravity and geometry, delivering life-giving water with almost no loss to evaporation. The true genius of the qanat, however, was its sacred origin. The mother well, the point where the tunnel first struck the hidden water, was often located within the grounds of a temple complex. Here, a sacred spring was not just a spiritual symbol, it was a managed public utility, its flow captured and directed by engineered tunnels that began in hallowed ground. This was infrastructure born from reverence, a physical manifestation of a divine gift. The construction of a qanat was a monumental undertaking. Teams of workers known as muqanis would dig a series of vertical access shafts down to the level of the aquifer, then connect the bottoms of these shafts with a gently sloping tunnel. These shafts, which look from the air like a line of craters marching across the desert, served as both ventilation and maintenance passages, allowing generations of workers to descend and clear silt from the water channel. Along the route, Persian engineers built sedimentation basins, chambers where the water would slow, allowing sand and debris to settle out in a remarkable act of ancient purification. By the time the water reached the city, it was clean and ready for use. Researcher Dr. Dale Lightfoot has documented systems that stretch for over 50 kilometers, all built with a gradient so precise that the water flowed steadily for centuries without a single pump. The final destination was often another temple, which acted as the city's water distribution hub. Here, at a sacred structure, community elders would oversee the allocation of water to different urban sectors and farmlands according to ancient and equitable rules. The flow was measured by time, with water rights carefully portioned out to ensure the entire community thrived. This was a system where spiritual authority and civic management were indistinguishable. The temple was not just a place of worship, it was the control center for the city's most vital resource. The persistence of qanat systems for thousands of years, with some still in use today, is a powerful testament to their effectiveness. They created sustainable urban environments in some of the most arid regions on Earth, a silent partnership between human ingenuity and the hidden gifts of the landscape. This ancient approach to managing a scarce resource offers a profound lesson for our own modern world, where many regions face escalating water crises. It proves that the most resilient solutions are often those that are woven into the very fabric of community and belief. This same drive to build sustainable cities through hidden water networks was also the foundation of the world's very first urban civilizations, born in the Fertile Crescent between two great rivers. The towering ziggurats of Mesopotamia were far more than stairways to the gods. Beneath their immense mud-brick cores lay a hidden foundation of astonishing complexity, a subterranean world that gave these sacred mountains their enduring strength. At the heart of Babylon, the great Etimenanke ziggurat was undergirded by a network of chambers and tunnels, spaces that served a silent, practical purpose. These were not empty voids. They functioned as storage areas for vital temple goods, as part of a larger water management system. and even as a form of early climate control, where the stable temperature of the deep earth could preserve perishable resources. The true genius, however, was in the very materials that held these structures together. Archaeologists like Dr. Maguire Gibson from the University of Chicago have uncovered foundations built with layers of reeds and bitumen. This was not primitive construction. The reeds acted as a flexible mat, allowing the entire massive structure to sway and settle slightly during an earthquake without shattering, while the bitumen, a natural tar, created a powerful waterproof barrier that protected the water-soluble mud brick from dissolving in the rare but devastating downpours. The placement of these ziggurats was a masterstroke of urban planning. They were consistently erected on elevated ground, a position that provided a commanding spiritual presence but also a critical practical function, offering natural drainage for the entire city that sprawled below them. Their foundations were often deliberately aligned with accessible underground water sources, turning the temple into a central node in the city's hydrological network. Cuneiform tablets describe these sacred complexes as distribution hubs, where resources collected as offerings were then managed and redistributed to the populace through a system of underground storage chambers. This reveals a civilization that saw no division between the divine and the municipal. The ziggurat was not an isolated monument. It was the functional, beating heart of an integrated urban system, its hidden engineering ensuring both its own immortality and the daily survival of the city it watched over. The sophistication of these solutions, achieving resilience through an intimate understanding of materials and landscape, stands as a powerful rival to many modern approaches. This profound integration of the sacred and the subterranean was not confined to the river valleys of the Middle East, but flourished with equal brilliance in the ancient kingdoms of Africa. The stone walls of Great Zimbabwe rise from the earth like a natural extension of the landscape, but their true strength was forged in the darkness below. This medieval African metropolis was not just a collection of impressive structures. It was a city powered by an intricate underworld of tunnels, chambers, and hidden waterways. While the towering granite enclosures captured the eye, a sophisticated network of drainage channels worked silently to capture the lifeblood of the region, water. These were not simple gutters. Archaeologist Dr. Thomas Huffman has meticulously documented how the city's builders carved precise channels that directed rainwater from the vast, curved surfaces of the buildings into a series of deep, plaster-lined storage cisterns. This system performed a delicate balancing act, preventing destructive erosion around the massive stone foundations, while simultaneously harvesting every possible drop of the precious seasonal rains. The entire urban layout was a masterclass in geological integration, with the positioning of royal enclosures and residential areas carefully chosen to align with natural rock basins and fissures that naturally enhanced water collection. This transformed the entire hilltop into a giant, sloping catchment area. Some of the subterranean chambers that branch off from these water systems reveal another layer of genius. Carved into the cool, stable earth, these rooms likely served as natural refrigerators, preserving food and safeguarding valuable trade goods like gold and ivory from the tropical heat, using nothing but the Earth's own constant temperature. This was a form of passive climate control built directly into the city's foundations. The entire design wove practical needs into a spiritual and political tapestry, where the king's control over water and storage was a divine right made manifest in stone and earth. This integrated vision created a sustainable urban environment that supported a population of up to 18,000 people at its peak, a thriving hub of commerce and culture in southern Africa. The complexity of these systems, developed entirely from a profound understanding of local granite and the region's climate, stands as a powerful challenge to outdated narratives that have long overlooked African technological achievement. Great Zimbabwe was not an isolated wonder, but a brilliant example of a universal principle, one that was also being perfected an ocean away in the ancient pueblos of the American Southwest. Perched high in the sandstone cliffs, the ancient cities of Mesa Verde appear to cling to the rock face, but their true strength was anchored deep within the stone itself. These were not just dwellings, they were masterpieces of integrated design, where every wall and chamber served multiple, interconnected purposes for survival. Beneath the visible structures, the ancestral pueblones carved intricate cisterns directly into the bedrock. These were not simple holes, they were part of a sophisticated water network. On the mesa tops high above, they engineered natural catchment systems, channeling every precious drop of rainwater through layers of sand and gravel. This acted as a natural filtration process, purifying the water before it ever flowed into the hidden storage chambers below. The water was then distributed through a network of small channels to different household units, ensuring each family had access to this vital, clean resource. The architecture itself was a form of climate technology. Dr. Catherine Cameron has shown how the entire village was positioned with remarkable precision. The structures were aligned to capture the low, warming rays of the winter sun, while the massive, overarching cliff provided essential shade during the scorching summer months. This passive solar design was complemented by underground chambers that leveraged the Earth's stable temperature, remaining cool in the heat and retaining warmth in the cold, creating a natural, year-round climate control system that required no fuel. Even the spiritual heart of the community, the circular kivas, were engineering marvels. These ceremonial rooms incorporated sophisticated ventilation systems. A central fire pit would draw in fresh air from an exterior shaft, while the hot smoke would rise and exit through a ceiling opening, regulating airflow and distributing warmth efficiently throughout the subterranean space. This meant that a sacred ceremony also served to heat adjacent living areas, a seamless blend of ritual and practicality. The entire settlement was a compact, urban environment where the line between spiritual architecture and life-sustaining infrastructure simply did not exist. Their profound understanding of hydrology and thermodynamics allowed them to thrive for centuries in an unforgiving landscape. The efficiency of this ancient, integrated design offers powerful insights for our own modern challenges in sustainable architecture, proving that some of the most advanced solutions are those that work in quiet harmony with their environment. This same drive to build resilient, subterranean-supported cities emerged with unique character in the island nations of ancient Japan. The silence within a Japanese coffin tomb is not merely the quiet of the grave, it is the stillness of a perfectly engineered space. These massive, keyhole-shaped mounds that dot the Japanese landscape are far more than royal burial sites. They are the apex of an ancient, integrated urban design. Beneath their serene, grassy surfaces lies a hidden world of hydraulic control. The burial chambers deep within were protected by an intricate network of drainage channels, carefully engineered to divert groundwater and prevent the catastrophic flooding that would destroy delicate grave goods and the integrity of the structure itself. Archaeologist Dr. Walter Edwards has studied the precise arrangements of stone and layered clay that wrapped these chambers, creating a waterproof cocoon that ensured the tomb's eternal stability. This was not a simple barrier, it was a multi-layered system designed to manage hydrostatic pressure and channel moisture safely away. The genius of the coffin, however, extended far beyond the tomb chamber. The entire mound was a landscape management tool, Their consistent placement on elevated ridges was a deliberate choice, granting them a commanding spiritual presence while simultaneously leveraging the high ground for natural drainage. From this vantage, they overlooked the very communities they spiritually protected, their foundations acting as a massive hydrological anchor for the surrounding terrain. The moats that often encircled them were not just symbolic boundaries separating the living from the dead. They functioned as practical, large-scale reservoirs and catchment basins, controlling runoff from the mound itself and regulating the local water table for the adjacent farmlands and settlements. The scale of these projects is a testament to a highly organized society. Constructing a coffin required the coordinated labor of thousands, all directed by engineers who understood soil mechanics, water flow, and long-term structural integrity. This was a society that saw no conflict between honoring its rulers and securing its environment, merging spiritual belief with practical necessity in a single, monumental act of construction. The sophistication of this knowledge, which allowed these mounds to withstand centuries of earthquakes and typhoons, completely challenges any simplistic view of early Japanese technological history. It reveals a culture that was masterfully engineering its world, both above and below the surface. This same drive to build resilient, water-managed cities flourished with unique character in the ancient kingdoms of Southeast Asia. The stones of Borobudur rest upon a secret foundation, a hidden mechanism of survival. Rising from the lush Javanese landscape, this massive Buddhist temple is a mountain of intricate carvings and silent chambers, yet its true genius is buried from view. Beneath the thousands of stone blocks lies a sophisticated drainage system, a network of hidden channels and porous layers that work in perfect concert. When the tropical rains come, as they so often do, water does not cascade destructively down the monument's sides. Instead, it is absorbed and channeled away through this internal labyrinth, protecting the elaborate reliefs from the erosive power of water. Archaeologist Dr. John Miksic has detailed how the builders used a form of passive climate control, designing the enclosed galleries with a precise understanding of airflow. Vents and gaps, invisible to the casual observer, allow air to circulate constantly, maintaining a stable temperature that prevents moisture from settling and damaging the ancient stone from within. The very location of Borobudur on a natural hill was a masterstroke of integrated design. This was not just for symbolic elevation, placing it closer to the heavens, but for profound practical reasons. The hill acts as a natural foundation, its slope enhancing the drainage system's efficiency and the ventilation principles that keep the entire structure breathing. Recent restoration efforts have peeled back layers of history to reveal even deeper secrets, previously unknown subsurface features that suggest certain chambers or conduits may have had a dual purpose. Some of these underground spaces might have been used for ceremonial gatherings, where the sound of flowing water beneath the floor would have added a spiritual dimension to meditation, or they could have served as resonance chambers, amplifying the chants of monks throughout the complex. This seamless fusion of spiritual ambition and hard engineering created a monument of incredible durability. Borobudur has withstood the immense pressures of volcanic eruptions, the relentless humidity, and the torrential downpours of the tropics for over 12 centuries. Its persistence is a direct result of this ancient Javanese mastery of materials science, a deep, intuitive understanding of how stone, water, and air interact over vast stretches of time. The temple is not merely a sacred site, it is a testament to a holistic philosophy of building, where every practical solution was woven into a spiritual tapestry. This same reverence for integrated, enduring design finds a powerful echo in the desert, beneath the sands of ancient Egypt. The polished stone floors of Karnak echo with the footsteps of countless pilgrims, yet the temple's true voice whispered from the world beneath their feet. This was not a silent foundation, but a living, breathing underworld of tunnels, chambers, and engineered water channels. These subterranean arteries did far more than support the massive stone columns above. They were the functional heart of the entire ritual complex. Deep within the darkness, priests monitored nilometers, sacred stairwells or wells that plunged down to connect with the Nile's groundwater. The precise level of the river, measured in these hidden spaces, was more than just a number. It was a divine message predicting the bounty of the coming harvest, a piece of critical state information gathered in a holy chamber. Egyptologist Dr. Mark Lehner has mapped how these systems were not passive observers of the river. They featured engineered channels with sluice gates and control mechanisms, allowing priests to manage water access, letting it in during the life-giving flood season and sealing it out when the waters receded. This was active hydrological management disguised as religious observance. The Temple of Horus at Edfu provides a written blueprint for this duality. Its walls contain inscriptions that describe underground chambers called laboratories, where sacred rituals for crafting divine statues were performed alongside the practical storage of precious ritual objects and even grain reserves. The spiritual and the logistical were housed in the same sacred subterranean space. Recent surveys using ground-penetrating radar have peeled back the layers of time to reveal a shocking scale. Previously unknown tunnels stretch for kilometers from the major temples, running directly toward the Nile. This suggests an integrated water grid, a hidden utility network that connected the most sacred sites on Earth to the river that gave them life. The temples themselves were not randomly placed. They were positioned with precise knowledge of underground water sources and specific geological features that amplified their ceremonial power, perhaps through natural acoustics or even subtle energy shifts. This profound integration of practical infrastructure with spiritual architecture created sustainable ritual spaces that operated flawlessly for millennia. The ancient Egyptian builders were not just master stoneworkers. They were hydrological engineers and urban planners whose greatest work was intentionally buried, creating a resilient system where the gods and the city's water supply flowed from the same unseen source. This same principle of sacred subterranean engineering was being perfected an ocean away in the heartlands of ancient Mesoamerica. The hilltop city of Monte Albon stands defiantly against the sky, a masterpiece of urban planning where every plaza and pyramid was part of a hidden hydrological machine. Beneath the grand main plaza, a network of canals and dams worked in silent concert with the architecture. The Zapotec engineers faced a critical challenge, managing torrential rains on steep slopes without losing the precious water to runoff. Their solution was one of elegant simplicity and foresight. They constructed check dams, small barriers placed across gullies that did not stop the water but deliberately slowed its frantic pace. This allowed the rainfall to percolate deep into the earth, replenishing the groundwater aquifers instead of carving destructive gullies down the mountainside. Archaeologist Dr. Joyce Marcus has meticulously documented how the entire city was designed as a catchment surface. The vast, stone-paved plazas and the angled roofs of temples were all engineered with subtle gradients, guiding rainwater into a system of drainage channels that fed a series of underground storage chambers. This ensured that the water that fell during the violent wet seasons was captured and saved for the long, dry months. The main plaza itself was the heart of this system, a ceremonial space that never flooded because its gentle slopes and hidden conduits directed water away with quiet efficiency. The spiritual life of the city and its physical survival were two threads woven from the same cord. This integrated design allowed Monte Alban to flourish as a densely populated hilltop capital, supporting up to 25,000 people in an environment that would have defeated a less ingenious society. The city's endurance for over 1,000 years is the ultimate testament to the success of this approach. The Zapotec did not conquer their landscape, they collaborated with it, creating a unique model of Mesoamerican urbanism that turned a mountain into a reservoir. This drive to build resilient cities through profound environmental understanding was a global phenomenon, finding another breathtaking expression in the ancient landscapes of South America beyond the Andes. The Brazilian coastline holds monuments built not from quarried stone, but from the accumulated remains of daily life. These are the sambaquis, massive mounds of shells and fish bones that rise from the shore, some towering over 30 meters high. For generations, they were seen simply as ancient garbage dumps, the refuse of hunter-gatherers. But we now know they were something far more sophisticated, concealing a hidden world of subterranean engineering. These were not random piles of debris. The builders intentionally layered the shells with clay and sand, creating a natural filtration system. When rainwater fell, it would percolate through these layers, leaving impurities behind and collecting as clean, fresh water in hidden reservoirs at the mound's base. This was a deliberate, engineered solution to the challenge of finding fresh water on a saltwater coast. Archaeologist Dr. Maria Dulce Gaspar has uncovered evidence that takes this further. Deep within some of the larger mounds are chambers and narrow tunnels, spaces kept cool and stable by the insulating mass of shells above. These likely functioned as natural refrigerators, preserving perishable foods like fish and roots for extended periods, turning the sambaqui into a communal pantry. The placement of these mounds was a masterstroke of integrated planning. They were consistently built at the perfect confluence of resources, positioned between rich fishing grounds in the ocean and accessible freshwater springs inland. This created a complete, sustainable settlement system where every need was met within a short distance. Some of the largest sambaquis reveal an even deeper level of foresight. Excavations show carefully constructed drainage channels carved through the mound's core. These weren't just for removing excess water. They were designed to direct nutrient-rich runoff from the decomposing organic layers toward nearby gardens or agricultural areas, effectively fertilizing the soil. This entire complex, from its water filtration to its food storage and waste management, was woven into a landscape that also served as a cemetery. The same mound that provided a community with water and preserved its food was also the sacred ground for burying its ancestors. This fusion of the practical and the spiritual created a profoundly resilient way of life, allowing these coastal communities to thrive in one place for countless generations. The sambaqui stands as a powerful challenge to old assumptions, proving that sophisticated, sustainable urbanism could be built with shells and earth, a hidden infrastructure supporting life along an entire continent. This same ingenuity in harnessing the earth below was being perfected in the deep, ancient forests of northern Europe. The stone towers of Sardinia stand as silent, brooding giants across the landscape, their true purpose locked within their labyrinthine cores. These nurag are far more than Bronze Age fortresses. They are the visible peaks of a vast subterranean world. Beneath their massive stone blocks, engineers carved sophisticated networks of wells and cisterns, capturing every precious drop of Mediterranean rainwater. This water was then channeled through hidden conduits to supply the domestic needs of the settlement and irrigate the surrounding farmlands, turning the challenging climate into a place of reliable abundance. The strategic placement of these towers was a masterstroke of integrated planning. Built on elevated ground, they offered a commanding defensive view while simultaneously functioning as the highest point in a gravity-fed water distribution system. Archaeologist Dr. Giovanni Liliu documented how the builders often incorporated natural caves and meticulously modified underground chambers. These spaces, insulated by tons of stone and earth, maintained a cool, stable temperature year-round, acting as natural refrigerators to preserve grain and other perishable foods for the entire community. Some of the most intriguing discoveries are the underground chambers connected by narrow tunnels that weave between the towers. A single complex might have multiple levels descending into the darkness, with rooms that could have served a dual purpose. One chamber might store vital grain reserves, while an adjacent space, with its unique acoustics or strategic alignment, could have been used for council meetings or sacred ceremonies. This seamless blending of the practical and the spiritual within the same hidden network created incredibly resilient settlements. The entire design showcases a profound understanding of local granite and the regional hydrology, a unique architectural solution developed over generations. The persistence of the Nurag culture for centuries, thriving where others might have struggled, is a direct testament to the effectiveness of this buried infrastructure. It represents a brilliant and often overlooked chapter in European prehistory, where survival was engineered from the ground up. This same drive to build sustainable cities through hidden water networks emerges with equal ingenuity in the arid heartlands of ancient Central Asia. The rolling grasslands of Eurasia are dotted with thousands of ancient burial mounds, silent hills that hold more than just the remains of the dead. Known as kurgans, these structures are the enduring monuments of nomadic cultures, and beneath their grassy surfaces lies a hidden intelligence. Far from being simple piles of earth, many kurgans conceal sophisticated subterranean systems that served both the spirit and the practical needs of the living. Deep within their cores, archaeologists have found intricate networks of drainage channels. These were not an afterthought, but a critical component, designed to protect the sacred burial chamber from flooding and water damage, ensuring its eternal integrity. But the function of these channels extended far beyond the tomb itself. They were engineered to manage surface water across the entire landscape, capturing rainfall and directing its flow to prevent soil erosion on the open steppe. This subtle manipulation of hydrology turned the kurgan into a sustainable feature of the environment. Archaeologist Dr. Elena Kuzmina has detailed the precision of this construction, noting how builders used layered stones and carefully placed clay barriers. These materials created a flexible, waterproof seal around the central chamber, a design that allowed the entire mound to shift and settle with frost heaves and minor earthquakes without cracking open. This reveals a profound understanding of geotechnics, an ancient science of building in harmony with the Earth's movements. The very placement of these mounds was a calculated decision. They consistently crown elevated ridges, positions that grant them a commanding spiritual presence over the land of the ancestors, while simultaneously leveraging the high ground for optimal natural drainage. This strategic positioning managed water runoff patterns that benefited the surrounding grasslands, essential for the herds that were the lifeblood of these nomadic peoples. Some of the larger kurgans reveal an even more complex purpose, with underground chambers that appear to have been used for storage or as ritual spaces long before they were sealed as tombs. Imagine a community gathering in a cool, subterranean room within the mound, a space used for ceremonies or to safeguard vital supplies, a place that was both a spiritual sanctuary and a practical resource. This seamless integration of landscape management with sacred architecture demonstrates how nomadic societies engineered sustainable relationships with their environment. They created durable, functional places that supported their mobile lifestyle while maintaining a deep, permanent connection to specific hallowed locations. The sophistication inherent in these earthen structures completely upends any simplistic notion that nomadic cultures were incapable of complex technological achievement. Their approach to landscape engineering, where a tomb also functions as a water management system and a community anchor, represents a vital and often overlooked chapter in the history of Central Asia. The enduring wisdom of these ancient builders, who solved multiple challenges with elegant, integrated solutions, offers a powerful lens through which to view our own modern struggles with infrastructure and sustainability. The buried infrastructure of the past is no longer a forgotten relic. It is a living blueprint for our future, as our modern cities strain under the pressures of climate change and resource scarcity. A quiet revolution is underway, with architects and urban planners looking back to these ancient solutions for inspiration. In Tokyo, a city battling severe land constraints, engineers are constructing massive underground cisterns, vast cathedral-like chambers designed to capture and store stormwater. This is not a new idea, but a direct echo of the immense reservoirs and filtration tanks built beneath cities like Petra and the Indus Valley, a modern application of an ancient principle for managing unpredictable deluges. Similarly, Singapore, a nation perennially concerned with water security, has developed a sophisticated system of underground storage and distribution that mirrors the genius of the Persian qanat, channeling every precious drop with maximum efficiency and minimal loss. The goal is the same: to turn scarcity into abundance through intelligent, gravity-fed design. The wisdom of ancient climate control is also being rediscovered. Engineering firms are now actively studying the passive temperature regulation found in structures from Mesa Verde to the Minoan palaces. By analyzing how these ancient builders used subterranean chambers, strategic ventilation, and thermal mass, modern designers are learning to drastically reduce the energy consumption of new buildings. The concept is simple yet profound: leverage the Earth's own stable temperature as a natural heating and cooling system, just as it was done thousands of years ago. This integrated thinking extends to water management on a grand scale. The holistic approach seen at Monte Alban or in the Khmer Empire, where every plaza and temple roof was part of a catchment system, is now a model for contemporary green infrastructure. Cities are replacing impermeable concrete with permeable pavements and rain gardens, designed not just to move water away, but to slow it down, filter it, and allow it to recharge depleted groundwater aquifers, exactly as ancient check dams and infiltration galleries once did. Even the sacred geometry that governed the layout of ancient cities is finding new relevance. Landscape architects are no longer seeing parks and plazas as merely decorative, but as functional components of an urban ecosystem. They are incorporating principles of alignment and flow that recall the precise positioning of Stonehenge or the Great Bath of Mohenjo-Daro, creating public spaces that manage water, moderate climate, and uplift the human spirit simultaneously. The enduring success of these ancient systems demonstrates a critical flaw in much modern development: a lack of long-term, integrated thinking. We often build for decades while they built for millennia. Their solutions were not single-purpose, but elegantly solved multiple problems at once, weaving together the practical and the spiritual into a resilient whole. By understanding how ancient civilizations created environments that thrived for centuries, we gain more than just historical insight. We acquire a vital toolkit for the future. The wisdom embedded in this buried infrastructure offers a clear path forward, one that prioritizes harmony with natural systems over brute force engineering. It is a reminder that the most advanced solutions are often those that are quiet, efficient, and woven directly into the fabric of the world. The mysteries of these ancient networks are not yet fully solved. What other secrets lie beneath our feet, waiting to be uncovered and adapted for the cities of tomorrow? Even with all we have uncovered, the ground beneath these ancient sites still holds profound secrets. We have mapped channels and chambers, but we cannot always know the minds of the engineers who built them. Was a hidden conduit beneath a temple purely for moving water, or was the sound of its flow an essential part of a sacred ceremony? The line between a municipal water system and a spiritual instrument is often impossibly blurred, and this remains one of the most heated debates in archaeology today. We are left wondering if our modern categories of practical and ceremonial would have made any sense to the people who use these spaces every day. The pursuit of answers is driving a new era of discovery, fueled by technologies that feel like something from science fiction. Muon tomography, for instance, uses cosmic rays from deep space to create X-ray-like images of structures hidden deep within pyramids and hillsides, revealing voids without ever breaking the ground. Advanced ground-penetrating radar now provides resolution so fine it can almost show the tool marks on a buried stone block. These tools are letting us see into the earth with a clarity our predecessors could only dream of, promising to unveil networks we do not yet know exist. This technological leap is matched by a revolution in collaboration. Archaeologists are no longer working alone. They are partnering with geologists who understand the stresses of rock, with hydraulic engineers who can model ancient water flow, and with materials scientists who analyze the molecular composition of 2,000-year-old concrete. Together, they are reverse engineering the genius behind these systems, figuring out not just what was built, but exactly how it worked and why it has lasted so long. Yet some of the biggest questions are not about engineering, but about knowledge itself. How did the precise standards for brick sizes and drainage layouts spread so uniformly across the vast Indus Valley? Was this a formal school of engineering or a slower, more organic sharing of ideas that worked? We simply do not know, and we are only beginning to grasp how these hidden grids dictated life on the surface. How did the placement of a water channel under a main street influence the growth of a neighborhood or the location of a market? This intricate dance between the world below and the city above needs to be explored in dozens of different ancient cultures to find common principles. The most exciting research may bridge the gap between the ancient and the contemporary. Future discoveries could well confirm direct links between these buried infrastructures and the living indigenous knowledge held in oral traditions for generations. The stories told by elders today might hold the key to understanding the purpose of a chamber we just unearthed yesterday. Every new finding, whether from a particle detector or a community story, humbles us. It challenges our timeline of progress and forces us to admit that our understanding is a work in progress. These silent, subterranean wonders continue to push the boundaries of science and spark our collective imagination, reminding us that the greatest mysteries are often buried right beneath our feet, waiting for the right question to be asked. These silent networks beneath our feet form a global testament to a forgotten kind of genius. From the hydraulic arteries of Teotihuacan to the concealed channels of Petra, the pattern is undeniable. Ancient civilizations possessed a sophisticated understanding of engineering and environmental management that we are only now beginning to fully appreciate. Their greatest insight was the seamless fusion of the spiritual and the practical, weaving municipal needs directly into the fabric of the sacred. This was not a primitive approach, but a profoundly advanced one. It created urban environments where a temple was also a water distribution hub, a burial mound was a landscape management tool, and a pyramid's foundation was a climate control system. This integrated design allowed metropolises to support vast populations for centuries, even millennia, while maintaining a delicate balance with their natural surroundings. They built for the very long term, achieving a resilience that many of our own modern cities struggle to match. In our current era of climate uncertainty and rapid urbanization, these ancient models are not mere curiosities. They are vital blueprints. They teach us that the most effective solutions are often holistic, solving multiple problems with elegant, integrated thinking rather than relying on technological complexity alone. The ongoing discovery of these systems is a powerful reminder that human ingenuity has deep roots. It challenges our linear timeline of progress and humbles our modern assumptions. The next time you look upon an ancient ruin, try to see beyond the visible grandeur. Consider the invisible world that pulsed beneath it, the hidden grid that gave it life, water, and enduring strength. What could our cities become if we relearned this ancient art of integrated design? I would love to hear which of these engineering marvels resonated most with you. Share your thoughts in the comments below and subscribe to join us as we continue to uncover the historical mysteries that reshape our understanding of the human